Hello student, and welcome to the course Urban Rail Transit Tracks, Stations and Yards. In the previous lesson, we explored the significance of concrete and steel sleepers as crucial elements in the rail track construction. Both types of sleepers have their distinct advantages and disadvantages. Now, let's continue our discussions on enhancing the properties of sleepers and delve into sleepers with different shapes and their diverse applications in various settings. Since the start of the railways, millions of wooden sleepers have been installed all over the world. However, in order to preserve them, they require treatment with creosote, which is known for having a negative environmental impact when it leaches into the soil and groundwater, and also for having carcinogenic effects. For this reason, the use of creosote is forbidden in some countries. Meanwhile, there are new types of sleepers made from 100% recycled polymers that offers a sustainable and maintenance-free alternative to timber sleepers, which have already been installed in a number of countries around the world. Composite sleepers and hybrid polymer sleepers are relatively new types of sleepers made of a mixture of plastic, recycled materials, and reinforcing fibers. They offer excellent durability, low maintenance requirements, and are lightweight, making them easy to install. They are also high resistant to rot, insect damage, and fire. Therefore, the sleepers have been developed indigenously in some countries as a replacement for wooden, even more concrete sleepers. They can be made from waste products such as used rubber tires, and the manufacturers claim a lifespan about 40 years for these sleepers. These sleepers are under trial and the results so far have been quite encouraging, where the sleepers combine the consistency and the durability of the concrete sleepers within the favorable damping behavior of the wooden sleepers. The main difference between composite sleepers and hybrid polymer sleepers is how they are reinforced. Composite sleepers are made by adding glass fibers to strengthen and stiffen the entire sleeper, making it very rigid and strong. However, this can also make the sleeper more brittle due to the glass fibers. On the other hand, hybrid polymer sleepers have discrete reinforcing elements, like steel bars placed strategically. This design prevents them from becoming brittle and breaking under heavy loads. Tests have shown that the hybrid polymer sleeper can handle extreme bending without breaking, unlike composite sleepers reinforced with glass fibers, which might not hold up as well. Because of this durability, hybrid polymer sleepers are great for damaging situations, like on bridges or where the ground doesn't absorb shocks well. They can handle high-speed trains and heavy loads without getting damaged. They are also gentle on the ballast, the bed that holds the tracks in place. New developments have found their way into the design of traditional ballasted superstructure. Ballast spreads the loads from the underneath the sleepers to the foundation. This loading causes pressure between the contact points of the grains, which causes the ballast roadbed to deteriorate. The grains wear and wander, the ballast becomes fluid, causing diminished drainage function, and the track quality decreases. Maintenance work is necessary as a regular basis, depending on the amount of tonnage which has passed. There is a direct link between the level of pressure and the deterioration of the track. Decreasing the average pressures on the ballast will lead to a lower rate of deterioration. To achieve this, wide sleeper was developed. Due to the increased width, these sleepers can provide a larger contact area with the ballast bed and the ground beneath, effectively distributing the load more evenly. The broader footprint of the wide sleepers offer potential benefits such as enhanced stability, reduced pressure on the ballast, and improved resistance to the track degradation. Wide sleepers are used in mainline and regional applications. The system is suitable for all the gauges and for either freight or passenger traffic. As a result of the appealing design and ease of maintaining its surface, it is also well suited for tracks in the train station and in urban areas. The wide sleeper solution furthermore lower vibration values, lengthen the maintenance intervals, and extend the service life of the track system. Wide sleeper tracks enhance riding comfort, environmental compatibility, and the cost-effectiveness of railway operations. A development from Austria is a frame sleeper or cross sleeper, which intends to replace the hold transmitting structure of the traditional ballast track. In other words, this double H-shaped concrete sleeper can be considered as two sleepers that are connected as a fastening system with a bridge. The bridge combines a continuous longitudinal beam with cross members. The beam is formed by sections in frames which are connected and held in place by the rail and the fastenings, which are situated at either end of the frame sleeper. The arrangement of 4 fasteners per frame sleeper creates a very high stiffness in the horizontal plane, supporting the stability of the alignment and increasing the buckling strength beyond the limits presently in existence. Hence, the running wheel load is transmitted in a continuous manner onto the ballast bed, reducing the pressure under the sleeper substantially and avoid most of the stress gradients. Technically, frame sleeper shares the same principle as with a wide sleeper, which is used to increase the bearing surface of the sleeper and thus decrease the pressure on the ballast. The elements are 2.4 meters long and 0.95 meters wide in 2 sets of the rail fastening per element. Between the fastening system, the rail itself supported by the concrete bridge which provides quasi-continuous rail support. An elastic pad is incorporated into the concrete structure at the frame sleeper bottom to improve the ballast concrete interface. Underneath the sleeper elements, a 12 mm thick polymer layer will provide a better spreading of the loading and additional damping. Test results showed a reduction in the sediments of the 2/3 compared to a normal sleeper. However, the frame sleepers, characterized by their limited contact between the sleeper and ballast, present a slew of drawbacks. The minimal interface between the sleeper and the ballast lead to the high local pressure, posing a risk of buckling, particularly when subjected to elevated rail temperatures. These sleepers also suffer from limited lateral resistance, making them susceptible to spacing-include vibrations that disrupt smooth operations. Moreover, their design necessitates considerable maintenance, causing frequent traffic interruptions. The wide steel sleeper was designed to provide excellent position stability and good recycling qualities. Additionally, the system is very versatile. The wide steel sleeper is suitable for new rail track construction, renewal and expansion, and may be used in normal wide, narrow, and multi-track sections. The wide sleeper is a construction made of steel. The form is created from 2 S-shaped, hot-formed, wide flange support and 2 straight grade sections with the same profile. The connection of the steel profiles is achieved using 2 lower and 6 upper cross brackets which are welded to the flanges. The wide sleeper also has 3 paired rail supports with the central rail fastening. As a special format sleeper, the wide steel sleeper is used today throughout the world. Its low height and width can be the solution to the problem of limited space. However, its shape was a challenge. A machine had to be developed to lay these sleepers in a rotated manner. They are used on the roads with high and low axle loads, even with speed may vary. When contrasting with traditional sleepers like wood, concrete, or steel, wide sleepers exhibit 4 distinctive characteristics. These encompass a foundational body casting constructed from supportive grid profile, boasting a unique wide bracket configuration, with a design that incorporates 3 distinct rail support sections per sleeper. Wide sleepers offer an increased level of stability. Notably, they also feature a dual rail support system, further enhancing their capacity to uphold the rail effectively. You now have got regular sleepers that support the tracks, but these are special ones too, and they're called switch barriers, which are used at places where tracks switch or cross each other. Although they look somewhat similar to regular sleepers, they're longer and have to be completely flat. That's because they need to work perfectly with the switches that help trains change track smoothly. Now, let's talk about the bridges. We know that the train go over the bridges sometimes to make sure everything stays safe and sturdy. There are special sleepers for those bridges. These are called bridge beams. They can be made of wood or composite materials, just like the regular sleeper, but they're designed in a special way to fit on a steel bridge. So next time you set a train track on a bridge or at a switching point, you will know that there are some cool sleepers working behind the scenes to make everything work smoothly. In summary, the choice of sleeper type depends on the various factors such as expected traffic load, environmental conditions, maintenance requirements, and cost effectiveness. Railway engineers evaluate these factors to select the most appropriate sleeper type for each railway project. Okay, in this lesson, we're expanding our knowledge by introducing a novel type of sleepers constructed from the composite materials. Additionally, we explore the utilization of sleepers with varying shapes as well as applications of the specialized sleepers in the bridge construction and other rail switches. Hope you catch everything about the railway sleepers. See you next time.